When designing a project, there will always come the time to make the first part. In this video, I will be making exactly that. This will be the first part of an entire series in which I will build an awesome machine tool that I will be able to use in my workshop. I'm not quite ready to share with you guys what the machine will be, but this will be the first part of it. And to be specific, or more specific, this will be the first part for an access drive of one of the axes of the machine. The part you're seeing on the screen right now is the part that we'll be making in this video. It has multiple features. It has a big hole for a bearing. It has a recessed top surface for locating a part with the circle. It has a few threaded holes and two countersunk holes to mount the entire unit on the machine. The locating recess that you saw on the part is to locate the upper and the lower part to each other. If you're interested how the mechanism works, you can pause the video right here. I will go into more detail in the future. This is how you will drive the machine. There's a knurled diameter that you can turn, and this will then turn the screw, and with that also move the axis. This will be a fully manual machine, so there will not be any part of it that will be CNC, at least not for the moment. And with that, let's start making the part. I will be making this part on the CNC machine because of the recessed surface on the top. That would be quite hard to do without a turning table, and I currently do not own a turning table. Obviously, there would be other ways to make this part, but I have chosen to use the CNC mill. I mean, if I have it, I better use it. I recently got this hand wheel for it that makes setting up the part on the machine quite a bit more convenient. You can move the machine in all three axes and then use the rotary encoder hand wheel thingy to move it more accurately with the smallest increments. Before I had to press with the mouse on the computer screen. I had to press arrows. They would always move way too much, and then you had to type in the command, which was quite inconvenient. And with this new hand wheel, I can set up the machine quite a bit faster. I'm still using the paper method for leveling. That's also something that I will be hopefully working on in the future to improve that. In the first setup, or in the first operation, we will be machining the front and the back side of the part with this tool. And you can see it's quite necessary to cut a lot of air here, because I cut off the part so crooked, because I'm really not that talented with the hacksaw. The machine doesn't work very well to cut a lot with the side of an end mill, especially not with this end mill. It's also probably because this end mill is not really made for cutting with the side. It leaves a tapered surface. That's why you can see these lines on the finished part. But for cutting this top relief, this tool actually works really well. The tool likes to cut 0.5 millimeter deep and 5 millimeters of radial engagement with the tool, and then the machine doesn't scream at you. The surface finish comes out very well, and it's just a way more enjoyable setup to work with this machine compared to milling the sides of the part, as you can see right here. The surface finish also gets pretty good for this machine. With this end mill, I'm just roughing all the features, and I tried to spiral in with this end mill, but it wasn't really working because the hole that I wanted to spiral in was too small and the end mill doesn't cut in the center, so it, after like half a turn, it started to scream. So I had to change to the finishing end mill for all further operations. But after that change, everything worked out pretty well. Here I spiraled down in a small diameter to get rid of the material in the middle, and then open up the hole by spiraling down in a bigger diameter. And after that I open up the bore for the bearing, and this was done with a 2D adaptive toolpath, I'm pretty sure. I could have pushed the end mill, I think, quite a bit more here. I just wanted to be quite conservative to not break it, obviously, because I didn't have any other end mill. And then I spiraled down here for the countersunk bores for the M8 screws to mount the whole assembly. And after that I spiraled down again to open up the countersunk bore. Here you can really nicely hear all the chips getting recut in this small hole. It really sounds very nice. Really doesn't, but it's quite hard to get the chips out there. But at least it was very satisfying to see this countersunk hole being cut and the surface that it left. The mirror-ish like surface. And then I took some measurements to see how accurate these parts came out, and it came out pretty accurate, or take them with a grain of salt. I mean, I'm just measuring them upside down with a caliper, so they're probably not very accurate. Now the next operation is finishing the outside diameter of the locating diameter. I'm not really sure why I offset it by 1/10 of a millimeter. The idea behind it was to get rid of the corner of the end mill, the radius of the end mill, but I can just make the chamfer on the counterpiece bigger, so it's not really that useful or necessary, but I think it looks cool. So that's that. And after that I cleaned up the bore for the bearings. I measured it after the first pass. I put in the offset in Fusion, re-exported the program and did it again to make it perfect, but I put in the error that I measured in the diameter, and the offset in Fusion just offsets the toolpath on both sides by this amount, by the amount you put in. So after that it was 2/300 of a millimeter too big, but I think it will be fine. In the worst case I can make the part again, but I don't think it will be that big of a problem. And then I drilled all the holes for the M4 threads. This always works pretty well, and now we're finished. I remachined the front and the back surface on the manual machine with a end mill that's better suited for cutting these faces. Overall the part turned out pretty well. If you're excited about this project and the future parts that I will be making, then you should subscribe. If you liked the video, you can like the video, leave a comment, and with that, thank you for watching, and until the next video.